Welcome to this IEEE Computer Society course on secure coding. Hello, my name is Jung Ryu. In this course, I will help you learn all the essentials of secure coding. Secure coding is my passion, and I hope that you will also feel more enthusiastic and confident about secure coding by the end of this course. Let's get started. Let's briefly discuss the goal of this course. The main goal of this course is to explore all the essentials of best secure coding practices out there. So by the end of this course, my hope is that you will gain all the practical knowledge regarding how to write secure code, especially within budget and time constraints, because that's the reality. Here is a rough breakdown of this course. The course consists of these 5 sections: Introduction, Vulnerabilities and Exploits, Countermeasures, Tools, Frameworks and Services, and finally Summary and Conclusion. Especially in the Vulnerabilities and Exploits section, we will look into many ways software could be vulnerable and also the ways attackers take advantage of those vulnerabilities. The topics shown here are only a subset of the topics I'm going to be presenting due to the space limit on this slide. So the first topic I'm covering in this course is Introduction to Secure Coding. It consists of 4 different sections. The first one is Significance of Secure Coding. The second section is Secure Coding Terminology. The next is Secure Coding Principles, and finally Secure Coding Resources. And the first 3 sections have quiz questions you could use to assess your knowledge. So by the end of this course, you should be able to describe why secure coding is important, define key secure coding terms, describe fundamental secure coding principles, and tell where to find useful secure coding resources. Let's discuss the first subtopic, which is Significance of Secure Coding. Why is secure coding so important? Because the bottom line is everything is manifested in code. That's what the end user is interacting with. No matter how secure your requirements are, no matter how secure your design is, no matter how secure your architecture is, it doesn't really matter unless those are incorporated into your software when it's actually implemented. So I would say the most important step in your software development life cycle is really the coding part, in that sense. Another reason secure coding is so important is the fact that software is bound to be vulnerable. They are keeping track of all the software vulnerabilities, the known software vulnerabilities out there on this website called CVE. CVE stands for Common Vulnerabilities and Exposure, and according to the CVE website, as of today, the total vulnerabilities that have been identified in various software out there is 62,485. But this is just the tip of an iceberg, because in many cases the software vulnerabilities are not reported to this database. Software defects are the manifestations of design flaws or implementation bugs. They are exposed under certain conditions, either naturally or artificially. The defects could be triggered artificially, especially when there is an attacker taking advantage of one or more vulnerabilities in the software. And the mechanism the attacker is using to trigger the software defect artificially is called an exploit. In this course, our focus is on these software defects triggered artificially through exploits. Commonly used coding practices lack the rigorous controls necessary to minimize the introduction of bugs into software, because security is often not a priority because of the time to market pressure, a financial burden, or afterthought. We can think of secure coding in the context of prevention versus intervention and do a cost-benefit analysis. In fact, ROI, or return on investment, for secure coding is pretty high. According to CERT, Computer Emergency Response Team, the ROI for secure coding is 2 to 3 orders of magnitude reduction in the total cost of repairing the code versus making the repairs after the fact. So it's always more expensive trying to fix the problems after the software is implemented. It's already been proven many times in various research experiments. So the sooner you spot software vulnerabilities and fix them, the better. Therefore, the goal of secure coding is to ensure that software function properly under malicious attacks, and also the prevention of software malfunction by removing or reducing implementation bugs as much as possible. But one thing to remember is these can be only done within your budget and time constraints. Even if you try to remove all the software vulnerabilities, it is impossible. In fact, there is no such thing as perfectly secure code. It's been proven. It is impossible to produce an absolutely bug-free software, especially when the software is non-trivial, and this fact has been proven mathematically. So theoretically speaking, the proof is not feasible, and at the same time, it is simply cost prohibitive. Even if you try to prove that your software has no bug, it is simply too expensive, and it is also impossible in theory. Therefore, your goal should be to do your best, to do your due diligence within your budget and time constraints. And this course is designed to help you do that by providing some practical solutions and tools. Congratulations, you just finished the very first topic of our course, and the next topic is secure coding terminology.